So besides the frequency distribution, measure of central tendency, and measure of dispersion, there are also other measures that can help us describe a collection of data. For example, skewness, kurtosis, and coefficient of variation. Skewness is the lack of symmetry of the data. So for grouped data, we have these two graphs to illustrate the skewness. If the long tail is on the left, then we say that this graph is left skewed or negatively skewed. And if the long tail is on the right, then we say that this graph is right skewed or positive skewed. Kurtosis provides information regarding the shape of the population distribution, and it actually used as a non-dimension measure of the height of the peak in a distribution. So it describes the peakedness of the data. And on the left, this data is more peaked, so it is called leptokurtic. And on the right, this one is more flat, and then this is called platykurtic. The correlation variation, CV, is a measure of how much variation exists in relation to the mean. So this is also related to a population. And the CV equals to the S divided by X bar times 100%. So because the standard deviation and the average have the same unit as the data point, so when they times 100%, this CV is represented into a percentage. I will briefly introduce the concept of population sample. So the population is a set of all items that possess a characteristic of interest. So this is the whole set of the data points that I'm interested in, or the whole set of the objects that I want to examine. I want to find the characteristics of all these objects. And for sample, it's a subset of the population. So if the population is too large, I cannot get every data point, then I select a subset of a population. These two graphs compare sample and population. So we use average and sample standard deviation to describe a sample, and these two are called statistics. And we use mean and standard deviation, the mu and sigma, to represent the characteristics of population, which are called parameters. So the parameter is a characteristic of a population. It describes a population. For example, the average weight of the population, the average weight of 50,000 cans made in a month. So this is all the cans that is made in 1 month, and this is the whole set that I'm interested to examine. And statistic is a characteristic of a sample. It is used to make inferences on the population parameters that are typically unknown. So the statistic that we got from a sample can be an estimator for the parameter of the population. So for example, the manufacturing factory that produce 50,000 cans per month, but they cannot inspect every can, right? They do not have that many inspectors, and therefore they take a sample of 500 cans, and then they find the average weight. So this average weight of the sample of 500 cans become an estimator of the average weight of these 50,000 cans. So we have our assignment 2 for the chapter 4, which are the questions 19, 21, 23, 25, 27, 28, and 31. And the due date is next Tuesday, and you need to show all your work to receive full credit. You cannot just give me a number of the result. And so your work should include, but not limited to, the formula that you use, the values you plugged in the formula, and the result. You can either type it and save it as a PDF file for your assignment, or you can write your assignment on a paper and scan it also as a PDF file. I'm only accept the PDF file because the PDF cannot be modified by myself, right? So whatever you submitted, it will stay in that format. And please submit your assignment via Moodle, and I do not accept the late work. So the time window will be cut off after the due date. Okay, so that's all for our assignment instructions.